I'm going to hand the reins over to Andrew to talk about why he tackled this project, why is this important, and also just to be able to share where he's at with it and next steps. So I will stop sharing my screen and Andrew, give you the floor to share your slides or screen.
Thank you. Okay, I will jump into it. So this is about generating API specifications automatically. So the problem this tackles is context where, so actually to begin, what I'm going to talk about, so I'm going to start with what the problem is. It's a problem of generating documentation and why it's a problem. I'm going to do a very quick live demo showing what the library does and like the general idea of this approach, and then talk a bit about what some improvements to this would look like and potential future work. So the problem is that if you have a documented API, when I say documented, I mean you have a specification for your API. So you have annotated endpoints or something along those lines such that you can generate an OpenAPI specification. Then that's a very good thing. If you do not have that, then you're in quite a bit of bother. And this is a situation that I found myself in recently, where I was essentially the front-end engineer working on a project that used a back-end API that was very large but undocumented. So this is the problem, and the solution to this at the moment, there's a few ways to tackle this. So the first one is to annotate the API itself. There are many OpenAPI annotation libraries. This used to be called Swagger. It's now called OpenAPI API. They've now switched that terminology, but many of you will be familiar with that. That is very good. It's the right approach. It's the correct one, but in practice, if there is no documentation already, then it's going to be very difficult. It's going to be extremely time consuming, and that's often prohibitive. The second approach, you can use structural information in the code base or other structured information that exists to infer what the specification should be. So for example, with Django REST framework, you have models that are very well defined and coupled to the implementation in the database. So and the responses themselves. So you can use that information to infer what the specification should look like. And there's a library called DRI Spectacular that will do that for you. And there's a few other approaches along these lines that try to automatically generate one for you just by looking at your code base. And then another approach is to use a proxy. And by that, I mean, so you have let's say you have your service, you have a proxy that is forwarding and doing that action. And then it will just essentially record what the requests and responses were. And then from that, it can generate a specification form for you, because it will know what, based on the observations it's seen, it will know what the type of your underlying API is for each endpoint. So these are some of the approaches that exist at the moment. But it's difficult, yeah. So as mentioned, there's quite a few issues that get in the way of this in practice. So doing this manually is very time consuming. Structural approaches rely on assumptions that may not be true. This happened to myself, for example. The assumption, so if you use Django REST framework if you use it well, then certainly that library could work. But in practice, for various reasons, there can be a decoupling from some of the assumptions of these libraries that basically mean that the output isn't accurate. And if it's not accurate, you really just can't use it. It has to be thrown away. Proxy approaches are quite difficult to implement. So it's difficult to set up the proxy. The information that you get is soon out of date. It's only relevant to the observations it's seen and the version of the endpoint at the time. Which is, yeah, this is the sale problem. And then ultimately trust. If you're not, you need to be confident that the output is correct. So I'm going to do a quick live demo on what it looks like, and then I'm going to talk about ways to improve it. So this website is actually just a demo page. The library itself is just this thing. It is this toolbar, and what it's doing is going to record responses. So using this panel, I can actually construct a network request in the browser, and we'll see that get fired in the network tab. So I'm going to mock a request, let's say, to pretend Google have an API that says something like that, So I'm going to make this post request. It's going to respond with 200 to Google. The request is going to look like this, and the response is going to look like this. So it's quite complicated. This is a default one that is a nice example because it contains different data types. And these data types correspond to JSON primitives. If I mock this JSON response, then I will see live demo problems. I will see, okay, so I've got the default one here. I will got example.com here, and here is my mocked response. So I've got this request that has been spoofed to example API. The payload obviously was the request that I sent, and the response that I get back from that, if I have a look at this, is as follows. So very briefly, this is a OpenAPI specification just for this endpoint, and I can do others as well. So I can say API 2, for example, and that will also go in here. So I now have both of these endpoints, and they all get structured in a way that is perfectly aligned to the OpenAPI specification. If I look at the structure of that, I can see this, and I can copy the entire specification using this. I actually won't show this because of time, but I can also generate client code for this in any language. So I've got this as TypeScript. I can also do this in even Dart, whatever, Golang. So I can generate client code from this automatically. That's a quick live demo. So how it works, it uses a service worker to intercept the requests, tease them onwards both to the library and then onwards as usual. The underlying type information is inferred from the request response pairs that are observed, and it emits an OpenAPI 3.1 specification or client code for any language. Not any, but you know. So how could we improve this? So this is currently only happening on the front end, which is just really a proof of concept. A better way to do this would be to have, say, a agent hub system. So using a technology called eBPF, which is basically a new approach to monitoring processes in operating systems, in NIX-based systems. It would be possible to record requests and responses very easily with far less overhead than using a proxy. And then that could be aggregated, sent to a hub, and done in that way. I'm going to end things in 10 seconds. The final thing I will say is that, yeah, there is one company that does this already. It's relatively new, but the costs of this system are very significant at $3,000 per month for 10 million requests, which is very easy to achieve when you have this kind of system. So this would be an open source solution to do this more efficiently and for free. I will end it there. Thank you for listening.
Thank you so much. That was great. Appreciate all your effort that you put into the slide deck. Really easy to follow. We do have some time for questions. So would anyone in the group like to ask Andrew any questions? And Ramia has put the project link in the chat as well, so everyone can give it a follow and also ask their questions in there as well. You can either take yourself off mute or you can throw up your hand as well. Do you have any questions?
Just a comment. Like I'm definitely a big fan of having good schemas for your APIs, and I've used OpenAPI a ton. And I think I like to have sort of a schema first approach, where the first thing I do is write the schema and then generate code out of that. And so using tools to do that out of OpenAPI or using GraphQL and stuff like that, but that's typically only an approach that you can do early on in a project, like when you're starting it out, and starting off with doing it schema first is feasible. But for a system that has a significant legacy to it, that's really, really challenging. And so I think that the stuff that you're doing is a really cool way of starting that process, right? Because once you've, if you've got no schema at all, using something like this is a cool way to bootstrap yourself to the point where you have a schema. And then, once you're at that point, then you can move towards, becoming schema first, which, yeah, I think often the piece that you're focusing on with this is a real stumbling block for legacy systems. So yeah, it's cool that you're, trying to solve that problem, because definitely there are a lot of people and a lot of companies out there with older systems who would love to modernize, but it's just, they just don't know where to start. So yeah, very cool approach. Thanks for sharing.
Thank you, Bill. Thanks for the comments.
Rick, I see you popped off mute.
That's cool. Yeah, a couple of quick things. a small one first. I know the OpenAPI specification allows JSON or YAML. Is there a switch in the version of the system you've got now that'll generate YAML documentation as well, or?
Actually, there is a function for that. It's just there's no button for it, but yeah, it's done. So if we wanted to generate that, it's possible.
That's cool. Love it. I worked a while back on kind of a similar sort of feature, but from a different direction. It was generating API tests from at the time, like you say, it was Swagger, from Swagger documentation. There was an additional plugin for parsing it in a way that ended up being readable by Jest, and then Jest would generate it was a wild project. So I kind of love the idea of making an entire tool chain out of, like, from an existing API that doesn't have any documentation. This would be able to generate the documentation, and then that system would generate tests. So you could basically say, this is how this API should work. Does it work this way? And it would all kind of come together. Yeah, I love it. Nice.
Thank you, Rick.